Here we have an example of a series circuit, and we know that this circuit is in series because if we start at the battery, the electrons, as they flow through the wire, they are forced to go through all of these resistors. They do not have any other path to choose from. So that's what makes this a series circuit. So we're going to start by filling in the variables that we know in our variable table. So first, at the battery, I have my total voltage. So my total voltage is 12 volts. Then I'm going to go around the circuit. I know at resistor number 1, I have a resistance of 220 ohms. At resistor 2, I have a resistance of 470 ohms. And at resistor 3, I have 1.2 kilo ohms. I can't have this kilo prefix. So what I'm going to do is I'm going to multiply this by 1,000 to get rid of that kilo. And I'm left with 1,200 ohms. So my rule for series circuits to get the total resistance is to add up all of my resistors. So I'm going to add 220 plus 470 plus 1,200 to get my total resistance of 1,890 ohms. Okay, so solving series circuits is kind of like solving a puzzle. We've got these pieces and I need to fill in the rest of the table. So what I'm going to do is I'm going to solve for my current by using Ohm's law. So Ohm's law, we've got voltage over current times resistance. I'm solving for current, so I know current is voltage divided by resistance. So to get my totals, I'm going to use the totals. So to get the total current, I'm going to take 12 volts divided by 1890. 12 divided by 1890 gives me 0.006 amps. Okay. So I'm going to put 0.006 amps. Now we also know for series circuits, we have another rule that the current is the same no matter where you are in the circuit. So I'm going to take 0.006 amps and fill it in to the rest of my table for current. Okay, now I can use Ohm's law again to find the voltage. So when I'm finding voltage, cover the V, I'm left with I times R. So I've got voltage 1, because I'm looking in the first column, equals current 1 times resistance 1. So I'm going to take 0.006 times 220. And get 1.32 volts. To get voltage 2, I'm going to use current 2 times resistance 2. Current 2 is 0.006 times 470. I have 2.82. And to get voltage 3, I'm going to do current 3 times resistor 3. So I've got 0.006 times my resistance of 1200. So if I do 0.006 times 1200, I get a voltage of 7.2 volts. I can check myself to see if I'm right because all of these voltages together should add up to be 12 or close to 12 because we rounded. So we got 1.32 plus 2.82 plus 7.2, and that gives me 11.34. It's close enough because we rounded, so we knew we'd lose a little bit of information when we rounded. Good job.